The final topic of this course is momentum. Momentum. So what is that? In the seminal paper from '93, Jägerdasch and Tittmann found that past winner stocks have on average higher returns than past loser stocks. Yeah? So the so-called momentum effect or momentum anomaly has been since then documented in various asset classes. Yeah? So not only we do not find it only in stocks, but also in commodities, currencies, and so on. So how can we implement this so-called momentum effect? Yeah? So there are obviously many different trading strategies that have been discussed in the literature, and we will now focus on some of those. Yeah? And we also discuss how to iteratively run this trading strategy using MATLAB. Yeah? So given, let us start with our data matrix. Given we have our data matrix that have column vectors of our stocks, of the stock universe, yeah. So that's now basically the presumption. And given we have that data, we want to test if the momentum effect exists in this stock universe. So what do we do? So let's say we have our n stocks. Yeah. So capital N denotes the number of stocks in our stock universe. So if you consider the S&P 500, then obviously n is 500. Yeah, so it all depends on the universe of stocks that we consider. So the first step of implementing the momentum strategy is basically, let's say we have a timeline here, yeah, t, and today we are here at time t is 0. Yeah, t is equal to 0. So what we do is first, yeah, we compound the cumulative returns, yeah, for each single stock in our stock universe. Yeah? Let's say from time here t is -1 until here time t is -6. Yeah? So we compound, we take the sum of the returns from stock I given this period here, from t-1 until t-6. Yeah. What we do is we do this for all n stocks. And we sort, basically we store the cumulative returns in a vector, yeah, in an n by 1 vector. So for each single stock we have a number, yeah, the cumulative returns for this period, and so on. And what we do then is we sort these stocks in an increasing, we sort this vector here in an increasing order from lowest cumulative returns to highest cumulative returns. What we do then is we check, okay, where are the 10% of stocks that have the lowest cumulative returns? Yeah? We call them the losers. And then we check, okay, what are the corresponding cumulative returns of those 10% of stocks that have the highest cumulative returns given this period. Yeah? We are here now at t is equal to 1, so in our first iteration. So, and those stocks that had the highest cumulative return in that period here, these are the winner stocks. The winners. And now remember, we sorted this vector here. Yeah? So obviously, yeah, we have here in an increasing order the lowest cumulative return until the highest cumulative return. So knowing that we have here a certain threshold. Yeah. Here maybe the limit here for the losers is maybe, I don't know, let's say minus 25% is maybe the corresponding value. Yeah. This is maybe, let's say minus 25% is the cumulative return of the last stock, or of the stock that has the highest cumulative returns in the loser group. Yeah? So all the other losers have less than minus 25% cumulative return in this period. And let's say the threshold for the winner stocks is something like, I don't know, let's say 25%, just to keep it simple. Let's say 25% is the lowest cumulative return of the winner stocks here. Yeah. So all the other winners have at least 25% cumulative return in that period. Yeah? So knowing our two thresholds here for we can now determine which stock in our vector that is not sorted, in the original vector, where are these stocks located? So we can form a binary vector of zeros and ones that gives us basically that gives us the position of where to find the corresponding stocks that are in this group or in the winner group. Yeah? So we can form a loop, basically. This is how we will do it in MATLAB, that indicates us where to find the corresponding stocks that are in the loser group, because they have a cumulative return in this period here that is below minus 25. So they get a 1 in the original vector that stores the cumulative returns, and a 0 otherwise. Then we form another loop that gives us those stocks that have a higher return than 25% in that period here. And these are the winner stocks. So we go back to the original vector then, to the unsorted cumulative return vector, and we give all stocks a 1 that have a higher value of 25% given that period, and a 0 otherwise. And this vector basically gives us then the winner stocks. It shows us where to find the winner stocks in our original unsorted cumulative return vector. Very simple. So knowing which are the stocks that are in the loser group and where are the stocks that are in the winner group, we can compound the predicted return in the next period here, and period t is 1, in the forecast period or holding period t plus 1. So we keep our positions constant for the loser stocks and the winner stocks. So knowing which stocks are in what portfolio, we buy the winners and we sell the losers. So we finance our position of stocks that we invest in the winner stocks by short selling the loser stocks. So it's a zero cost strategy. Okay. So the return spread between the winner stocks, the return that the stocks that are in the winner portfolio generate in the holding period, minus the returns of the loser stocks, that's basically our profit. And what Hegedus and Titman found out already in the 93 paper is that on average the stocks that are in the winner group, or the spread between the stocks that are in the winner group and in the loser group, is about 1% per month. So in the next period, now we are at time t is equal to 2, the next iteration. So obviously then our time t is 0, it moves now one period ahead. Now we are here, and we do the same thing again. We skip the the most recent months, yeah, and then we cumulate the return from t minus 1 until t minus 6 again. Yeah? So we move the time window 1 month ahead and do the same thing over again. Yeah? Now our t is 0, obviously is here. So again, we consider our n stocks and our stock universe. Again, we form a vector, n by 1 vector, where we store the cumulative return in this period here, in this time window, for our n stocks. Again, we get some values here for the cumulative returns for each of the stocks. Yeah. What we do then is we sort this vector again. We sort it in an increasing order. Yeah, in an increasing order. Then we can again determine, okay, where are the 10% of the stocks that have the lowest cumulative returns, where to find the 10% of the stocks that had the highest cumulative returns, given t is equal to 2, the next time period. Again, we can determine the threshold here, yeah, the cumulative returns that are here, yeah, of the last stock in the lowest cumulative return group. Yeah, this is our threshold. This is maybe in the next period, I don't know, let's say it's minus 27%. Yeah, so all stocks that had cumulative returns in that period here of less than minus 27%, they belong to the loser group. That are our loser stocks. And then let's say the threshold for the winner group is something like, I don't know, let's say plus 26%. Yeah, so that means all stocks that had a higher cumulative return of plus 26% given that time window here, they are in the winner group. Yeah, these are our winner stocks. Again, we can code, knowing these two thresholds, we can determine where to find the loser stocks and the winner stocks in the originally cumulative return vector. Yeah? Again, we have two dummy variables. Yeah? We can, or binary variables consistent of zeros and ones, yeah? That indicates us, let's say, first the losers, where to find the losers. Okay, that means we go through this unsorted cumulative return vector and check where are the cumulative returns that have a value of less than minus 27, yeah? And we give them everywhere where the value is below minus 27, we give them a 1, otherwise a 0. Yeah? Let's say we have this kind of vector here. Yeah? It's a binary vector of 0 and 1, which indicates us the losers. Yeah? And then again, we can do the same thing for the winners. That is, okay, we go through this vector here and check wherever the cumulative return is larger than plus 26%. Yeah? And whenever this is true, we give them a 1, and otherwise there's a 0. Yeah? Which gives us then the indicating vector, or the binary vector, where to find the winner stocks. Yeah? So knowing where to find the loser stocks, and knowing where to find the winner stocks, we can again calculate our zero-cost portfolio. Yeah? We know now in our data matrix where to find the corresponding stocks that are in these two groups. Again, we short sell loser stocks, take the money and invest them into the winner stocks. So we keep this portfolio 1 month ahead in the holding period, t plus 1. And the spread, the return spread between the average return of the winners minus the average return of the losers is again our profit, our zero cost portfolio. So this procedure here is always the same. Okay, so we go through our stock universe, compound the cumulative return in a certain time window here. We determine where to find what's the threshold here. Yeah? And obviously this depends also how we operate. Okay, in this example here we have obviously 10% of the stocks in the loser group and 10% in the winner group, and this is called deciles. Okay, so we divide our n stocks into 10 groups, deciles, 10 times 10%, and then we take the upper 10% and the lower 10%, and this basically forms our zero cost portfolio. Other papers, if you have less stocks available, yeah, if you have the S&P 500, you have 500 stocks obviously, so you have 50 stocks in the winner group, 50 stocks in the loser group, and so it's a well diversified portfolio. But if you have, let's say, if you have currencies, if you operate with currencies, that for instance the G10 currencies, with a 9 currency pairs, obviously, so then you would operate with 3 groups. Okay? Then you would have 3 groups consisting of 3 currencies, yeah? And you would basically short sell 3 currencies and you would buy 3 currencies. Yeah? So we have then terciles. Terciles, which means that you have 3 groups. If you have stocks and you have, like, let's say, many stocks, you have, I don't know, let's say you have 100 stocks and you operate with terciles, then you would basically have 30% of the stock, 30 stocks in the loser group, 40 stocks are in between, yeah, you skip them, they're in the middle group, and 30% of the stocks are in the winner group. Yeah, so it's 30, 40, 30 usually. But if you have just 9 currencies, these people who basically operate or who implement the momentum strategy in the G10 space, where you have 9 currency pairs, they usually take 3 currencies in each portfolio. So it all depends. Some papers operate with quintiles, which means you have 5 groups. Each group has 20%, yeah, of the assets, and other papers, they have quartiles, yeah, which means 25% in each group. Then you have 4 groups. So it all depends on how many assets you have, but you have somehow to ensure that you have a well diversified portfolio, yeah, in the winner and in the loser group. Because obviously the momentum anomaly is a phenomenon that is defined for the average, for an average of stocks, for a well diversified portfolio. So this momentum effect, yeah, that we have these